I'm going to present something a little bit different, but exactly the same, with the same intent than Kevin. And definitely the trip that we made today was a good occasion to uh, assess. And I fully agree with the approach that. So I'm I've done in northern Quebec and published with this group of people. And we have been mapping permafrost in the villages of Nunavik. Nunavik is somewhat like the borough, the northern borough. We have 14 communities with one general administration that is called the Katsivik Regional Government. And we were asked by the provincial government of Quebec to map the permafrost in the communities. Very accordingly to the spirit that was just described by Kevin. And so this is the map, permafrost map of Quebec, and the following one is the map of permafrost at the temperature at the top of permafrost, T-top. And you got the community names and the number of people per community. So the largest one is Kuujjuaq, which is the capital of the region. And second largest is Puvirnituq. And Kuujjuaq is the only one of the 14 communities that does not have permafrost in the built environment. And as you can see, the temperature at the top of the permafrost, they are not that cold, not as cold as over here. The coldest is in the Salwit and Iwivik region at about -6. And when we get further south, getting close to the tree line and this continuous zone, we are close to 0 degree, -2, -3, and -1 in Kanik, Sorojwak, and Kuujjuaq. So that's important to understand for what's coming up. The villages have been expanding, and because of fast growing population, you have example over here of Puvirnituq. I will go because I want to explain the most important things, and I just show what in our region what the same issues that we have been discussing over here. These are the climate projections for northern Quebec and until the year 2100, and according to different scenario. Oops, sorry. So we have over here the past temperature since it's reconstructed. This is the actual readings that we had. 2010 was a very warm year. It's way above the others. And these are the projections according to the same RCP scenarios that Kevin just mentioned. So it's going to warm up. It started to warm up, particularly since 1992. Here is a case where Salwit is one of our worst case, most difficult one. There was an active layer, doesn't that? I'm looking actually active layer detachment failure in '98. This development was stopped, and then the development of the community was stalled for 10 years until we made the permafrost characterization and defined techniques to approaches for expansion. And this community also has active layer detachment slides that occur most often at the end of the summer during the particularly warm years. So we have problems with housing. This is a very recent house. This one is pictured in 2021. It's only 1 year old, and as you can see, it's already formed, and there's thermocast over here. There are some problems in streets, at villages, and so on. Impacts of permafrost, I won't go through in detail. I think we have seen enough today. And for example, and this is a water problem in Salwit because of settlement, and the water gets ponded, very similar to what we've seen today. And to characterize permafrost, of course, I agree 100%. The best tool is drilling that is supported by geophysics. And we had a problem. Then I'm moving more on the side of planning and design and also the the culture of the construction industry in our region. You can see here the most recent development are the ones that have been the most particularly affected, and it's because of poor knowledge by our engineers and our planners. People tend to target flat areas for constructions, and most of the times these are the areas below the low ground where we get the marine clays of the post-glacial transgression, instead of contrary to Greenland, where people tend to avoid the bedrock outcrops. It's a very different culture. So in this project, well, I won't go through all because it's too long, but we just mapped the permafrost at villages, and we assess also the risk of natural hazards, and we calculate also the impacts of climate change on permafrost for the future. This is, for example, some of our drilling operations. And we use the ground penetrating radar. For example, over here, it's the community of Kanyik, Swabijuak. This is the GPR. And for example, in that particular case, we had good penetration. The environment is sand and gravel and flugoglacial material. So we can see stratifications in the sand and gravel beneath the surface. We use a GIS application. It's all described in this recent paper in details. If you want to read it, it's in the journal Arctic Science. It came out in May, late May. Oh, it's on the stick that was provided to you. Thank you. Next, so this is an example of the maps. You have for 4 maps per community. So one is the superficial geology. It's closely related to the permafrost conditions. For example, the darker purple is where the ground ice is. The light gray tones is bedrock and with a thin till cover. And this is the result of the addition of maps, the layers of maps that I just showed previously. And the red areas are the one that normally should be avoided or that need special construction techniques. Green is easy to build on, or at least it's stable. And yellow are places which are either poorly known or that need special construction technique. The last one, I won't talk too much about it today. It's an assessment of risk of hazard. For example, just for this example, this is the risk of coastal flooding over here in blue. For example, there are the 4 maps for Kralevik. And we have thermistor cables in almost all of the communities. We have been using them to calibrate model. One dimension model going down to depth, and the models are calibrated with the properties, the ground properties measured along the drills. And these are the projections. For example, for this particular case in Salwit, we have it for each village in the reports. And how fast permafrost is going to degrade depends very much on the sorry. Depends very much on the scenario, the climate change scenario. What we think is that for the next 10, 20 years, probably scenario 4.5 is the most probable because it's in line with the observations that we have in the ground. It's just in the consummation. But with the present political situation and the lack of action by the international community, eventually a scenario probably 8.5 will take place. And if you look at both of these, that means in a place like Salwit, the active layer will get in the coming years, and 10, 20, 30 years will already get thick enough, deep enough that we will have a lot of settlement in the community. So in each community, in each community, for the report, we state the current situation. We assess the possibility for expansion and adaptation. That is where are the stable ground. What is a timeline for decision making depending on the climate options, and what specific recommendations we make. They are rather the same for all the communities. And I insist that urban drainage plan are key to preserve the permafrost in the built environment. And then a related issue is that in the Nunavik, we have been building on pads mostly, and the culture of the industry has been to exploit gravel pits and build pads and build a very thick pads, and they have come to the way, for example, even building packs or pads over bedrock, which is very solid. In fact, the pad is not necessary at all for the structural stability of the building. But now what they do is they fill their lot and they make wide, flat, open lots, 30 meters by 30 meters, and they have sheds and they put their instrument, their vehicles, their skidoo and so. So people got used to have those large flat areas. But the issue is that they run out of gravel. So we have to change the construction techniques. And in the follow-up of the mapping project, the Quebec government and the federal government asked my team to do a survey to look for a solution. So we met all the stakeholders, the organization, political companies. Kativik Elisar-Lerinik is the school board. Kakelik is a corporation for landholding corporation in Salouet. Kativik is the regional administration and so on. Construction companies, drilling companies, and also government agencies like Hydro-Québec, who builds the power plants, Transport Québec, Ministère des Transports, who maintains and builds the runways, and the federal government who pays for the housing. So those communities are now actually out of gravel. And by talking with all these groups and all these people, they were very generous in their explanation. They really wanted to collaborate, and we found out that one of the main issues to coordinate is a lack. In fact, it's a lack of coordination. And all of these important organizations, every one of them, they work in silo. They don't work together. They really don't help each other, and they don't share very often they are in competition for the gravel. They are competition for renting a drill, or the other competition for renting trucks or stuff like that. And also they all share the same logistical problems of shipping all the construction material and the equipment north. Everything comes by ship in origin. So,
Michelle, 2 minutes.
Okay. So this is an appraisal of the cost, or these are the projects they told us, and the approximate cost that they are of what they want to do for the next 10 years. And we came out with a very small and underestimate, in my opinion, perspective of over $6 billion of construction between 5 and 10 years. And that's about 700 buildings without counting roads and reparation, maintenance of runways and stuff. So earthworks, foundation, production of granular material, pile installation for all these projects will be considerable. Some communities have started to use the maps. For example, in Ujuak, they benefited from some other project. They used the drill, they blasted bedrock. They have started to build on the hills, as you can see over here. And there are some models. For example, this little house is the research center or Université Laval. I drove the pile myself. Well, I asked the company and I hired them, and they drove the pile. It's on piles. And we provide examples from other areas. This is in Nunavut, north of Nunavik, where the buildings are built on steel piles, and they don't use much gravel. There are other examples, and you can have even like your very big buildings are on piles on sloping bedrock, and it requires much less gravel. This house is particularly interesting. It's in Kugluktuk, Nunavut. It's all bedrock, and it's all on piles, steel piles. So, and another approach, you can build on piles, and you can also do urban planning and land use planning. It's very key to, for example, avoid overspreading the communities, use the space on civil ground that has not been used yet enough for construction. So these are the final recommendations of this project that we just submitted a report last week to the governments. One issue is the budget for our saying was, and the call for bids was come at least 3 years in advance for planning, or otherwise the construction is they have difficulty they don't have enough time, for example, to build pads or to have the construction or to plan the lots and so on. The municipalities, the Catholic regional government needs more funding for support its infrastructure development. We have to make concerted land use planning and team projects for community expansion projects. And we recommend the government equip the communities with crushers, drills, and stockpiles. We have calculated that would cost about 80 to $100 million. But considering the total cost of all the construction that is coming in the 5 to 10 years, it's only 1.5% of the total cost of the project. But we just want to use this argument to show how little that is. In fact, it takes if we coordinate and we make the right investment to definitely probably adapt the villages to climate change. And this is, of course, the villages and the corporations of the Inuit Corporation, they must, of course, be part of the solution. And also we must consider that this is an opportunity to create jobs right in the communities to provide the services to the construction industry. And it is necessary to adapt now, not wait. All the buildings that we're making now and all the plans that we're making now, they will be stable if we do it properly forever. That's when I would call that a one shot or one large action for adaptation at this moment. Thank you.